All right, so this first problem gives us a circuit with some flip-flops, and we're supposed to show the sequence of what happens after 5 consecutive clock cycles, starting with, oh, and I had a typo on here that I meant to change. On the circuit, leave this as Q1, but the one underneath it should be Q0. So starting with Q1 and Q0 equaling 0, we want to find out what happens for 5 consecutive clock cycles with this input of B. So the inputs are 1, 0, 1, 1, 0. And it's showing up fine because I can't see the screen. Okay, all right.
Do you want to Google it?
No, I just let me know if, and also let me know if I forget to share the screen, because sometimes that happens and then I don't find out about it until like I'm already done with the problem. So if you're on Zoom and I don't share the screen, please remind me to do that. Okay, so when we do these kinds of problems, we always are looking back at the value of Q from the time before, because that's the value that's going to be sitting on the flip-flop at the change of the clock cycle. Now this particular one is a negative edge clock cycle, but it doesn't matter because it's the actual clock that's connected to the clock. So it's happening at the negative edge of the clock and not the positive edge of the clock, but that doesn't really matter. It does matter if you have something else going into the clock, and we'll see how that works after we finish this one. Okay, so when we start, we're saying B equals 1. So for B equaling to 1, it doesn't really matter what the other value is for the OR gate, because for an OR gate, as long as one of them is 1, then our answer is going to be 1. And this is a D flip-flop, and Q follows D, and so Q will be 1. And so Q1 is going to be 1. Now Q0, our input into T is B equal 1. And what does a T flip-flop do when its input is 1? It toggles. And so since it toggles, we have to know what it was before, and what it was before was 0, and so it will become 1. And F is the AND of Q1 and Q0. So the AND of Q1 and Q0 is 1, the AND of 1 and 1, which is 1. Hold on a second. Okay, is the sound still working online? Is it better? Can y'all hear me?
Yeah.
Okay, all right. And there's not an echo?
No, I don't hear an echo.
Okay, great. Okay, all right. Now B is turning to 0. And so it's important to know what the other input is to our OR gate. And so to figure that out, we have to look at the value of Q0 from the time before. So the clock cycle before, Q0 was 1, which meant the naught of Q0 was 0, and that was the other input to this OR gate. And so on this clock cycle, our input into the top flip-flop is 0, and it's a D flip-flop, so our output is also 0. And since B is our input into the T flip-flop, what does a T flip-flop do when the input is 0? Stays the same. Last time it was 1, so it'll be 1, and the AND of 0 and 1 is 0. Okay, and now this time we have, let's see, Q0 was 1, and so the not of Q0 is 0, so that's this input up there. And Q0 was 1. All right, and B this time around is 1. So I have the OR of 0 and 1, which is 1, which makes Q1 1. B is 1, so we have a 1 input to our T flip-flop. That means it's going to toggle, so Q0 becomes 0. And then the AND of 1 and 0 is 0.
How are you?
Yeah.
How you get 0 Q0?
Yes. Okay, so the way I got Q0 was B was given to me as 1, so B is 1. 1 is the input into a T flip-flop. When a T flip-flop has an input of 1, it toggles. And so you have to look at what it was last time, which is 1, and it'll toggle from that, which means to flop, to change. And so it's 1, so it'll become 0. So when the input to a T flip-flop is 1, then it just reverses its value.
Okay.
Yes?
So what's the difference between that and the D flip-flop?
For a D flip-flop, the output for a D flip-flop is the same as the input.
Oh.
So Q follows D. So Q is whatever D is. So for a D flip-flop, Q, if the input is 1, the output of 1. If the input is 0, the output is 0. For a T flip-flop, if the input is 0, the output is just whatever it was before. It could be a 1 or a 0. You have to know what it was before. And if the input is 1, it's the opposite of whatever it was before.
I would explain how I kind of do the practice test.
Yeah.
Based off of a B. So that's why whenever we have that first one for the B is 1, we got that first one. With B 0, since B was 0, it's whatever, it stays the same, so it stays in 1, that's why.
That's right.
Okay.
Yep. Okay. And then F is the AND of Q1 and Q0, and the AND of 1 and 0 is 0. All right, on the next clock cycle, B is again 1. And it's important to know what Q0 was last time. Q0 was 0. That means the not of Q0 was 1, so the other input for our OR gate is 1. So the OR of 1 and 1 is 1. That's a D flip-flop. Q follows D, so Q1 will be 1. B is 1, so the T flip-flop will toggle. It was 0 before, so now it'll become 1. And then F is the AND of 1 and 1, which is 1. And then for our last one, we have B is equal to 0. So in this case, it's very important to know what the other input is to the OR gate. The other input to the OR gate is the not of Q0. So the not of Q0, you look at what Q0 was last time, it was 1. So Q0 was 1 last time, so the not of Q0 is 0. So the two inputs to my OR gate are 0 and 0. The OR of 0 and 0 is 0. So Q1 now is 0. B is the input into the T flip-flop, and an input of 0 means you don't change, and so Q0 is 1. And so my output is the AND of 0 and 1, which is 0. Okay, so any questions on that?
Well, I just wanted to clarify, so the AND of a 0 and 1 equals 0, but the NOT of a 0 and 1 equals 1?
The OR of a 0 and 1.
The OR of 0 and 1 equals 1?
Yes, yeah. So, yes. So if I have X, Y, X and Y, 0, 0, 0, 1, 1, 0, 1, 1. In order to get a 1 from an AND, they have to both be 1s. And for an OR, zero, 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 1, 1, 0, 1, 1. Only one of them needs to be a 1, but it's okay if they're both 1s. And the NOT just toggles it. So the NOT of 0 is 1 and the NOT of 1 is 0. Other questions? All right. Well, I am going to stop this recording.